Boyan Mihaylov.
All right, welcome everyone to today's last session where we are going to talk about WebAssembly. Before I begin, just of curiosity, how many of you have heard about WebAssembly? All right, all of you. And how many of you have tried it out, like to do some stuff with it? All right, just a few of them. Great. Well, I hope that after today's session you'll get a bigger will to go and try out something with WebAssembly. WebAssembly is a compile target for the web. It allows us to compile from C and C++ or other statically typed languages to a binary code that can be run into the browser. This allows us to reuse code and allows us to build highly efficient web apps that we can build on top of that, something that has already been written for us. Let's have a look at this very simple JavaScript function. How many of you write JavaScript, by the way? All right, oh great, then you love JavaScript. So you know, this is very simple function that adds two numbers, right? Or, well, I want it to be numbers, but the thing is that JavaScript is highly dynamic language, so I don't really know if this is numbers that I'm going to add here. And the virtual machine has to check all the different possibilities. So we can maybe add a string to a number, maybe a string to an object. These are like really weird cases that you have to do because you don't really expect this to happen, but in practice it could happen. So the virtual machine has to take care of all these things out there. And if you write many things in JavaScript, you have probably realized that JavaScript is not really, a language is not really, concise. The things are not really consistent there, what is happening. So it kind of makes you really annoying that you have to deal with such things, especially if you have had a bug that you've been working on and, all day working with JavaScript, and you kind of stand there and listen to JavaScript all the day, and when you have first time for it, you just turn around and leave the building because you don't really want to talk about JavaScript anymore. Or maybe when you go out and try to do something, you kind of get drunk because JavaScript has really filled your head with really amazing stuff. So JavaScript, it has its problems, right? So we can do something better out there. And if we have to go some years back to see what the problem with JavaScript is, JavaScript was created in just 10 days, in 1995 by Brendan Eich. And, the first couple of years, it hasn't really been used for something useful. Maybe someone has used the click function of a button, or there's some small animations, until in around 2008, when people started using it more and more. jQuery became a thing, so kind of developers started using it, and browser vendors realized that there is a potential in this, so they started something called the browser wars, where each browser vendor began optimizing its virtual machine. So we have the Chrome, Mozilla, later on the Internet Explorer, and this became like a big thing. And become so powerful that, after having JavaScript on the client, then we said, well, why don't we get it on the server as well? And that's how we get Node.js, right? We could reuse all these things that were done on the client, all these performance optimizations, and put them into the server. But now we are reaching a certain point where optimizing JavaScript, it's not really feasible anymore, because it has reached a certain point out there that there isn't anything more we can do to optimize this language and the browser machine. We try to do something else then. We try to see, well, we love .NET, we love C#. Can't we use C# into the browser? Well, we could. We had Silverlight. We had some other alternative before that, like Flash, Java applets, right? But they were trying to solve kind of the same problem, reusing code written in some other language and putting it into the browser. But we didn't really work well at the end because it wasn't a right model for end users to deal with that. So what's the difference with WebAssembly then? What can we expect from WebAssembly that we hadn't had before? Well, the first thing is that WebAssembly is going to reuse all the architecture that we have for JavaScript today. It's going to live in the same sandbox environment as JavaScript is. And if we take a look at this architecture of what the browser, like in general, looks like, we have like on the left side, we have the JavaScript, like the parser, the compiler, etc. On the right side, we have all these APIs dealing with the DOM, with the app, WebSockets, web audio, etc. You know, all this thing is separated by the sandbox or surrounded by the sandbox and separated by other security policy like same origin policy, etc. So we have a pretty good security architecture in our browser. And WebAssembly is going to reuse all these things. So it is going to live where JavaScript lives today, which means that all the effort that we've put there, it is going to be reused. JavaScript has been basically implemented, or the parsing, the compiling time has been implemented by every virtual machine in a different way. Although they do kind of the same things, still it's different, and you can't really predict how a JavaScript function or application will perform under the different browsers. And if we take a look at this diagram, what's happening with JavaScript, basically it's a textual language, right? So we have to parse it. And then we have to do some optimizations. Most of browsers, they use something called just-in-time compiler. So basically they're trying to do some guesses about your JavaScript code and then run the code and see if the guesses are true, or if not, they are kind of re-optimized and throw away. So now there is this process because of the dynamic language of JavaScript. And you know, the execution is then longer, and we have the garbage collector afterwards. So if we have to take a look at what WebAssembly would look like, it would be something like this. WebAssembly is a binary language, so we are not going to parse it, but instead we're going to decode it. And decoding takes less time than parsing. So already there we have some optimizations. Furthermore, we have already compiled to WebAssembly, so we have already kind of provided a lot of optimizations to the browser. So the browser virtual machine doesn't have to do much there. So we already have skipped part of this. And WebAssembly is a type language. So we know for sure that when we have two numbers, there will be numbers and nothing else. So we could skip all this guess and see what's happened way of just-in-time compilations that we have out there. WebAssembly allows us to reuse code. So now we could take all these C and C++ libraries that we have out there and just compile them and call them like a normal JavaScript function. So we have also solved the way of reusing code that the other approaches couldn't really solve in a nice way. Very important aspect of the project is that it's a joint venture. You know, we have seen many different projects, like cool projects started by maybe either Mozilla or Google, and some of them live, some of them die. But you know, in our web world today, for a project, in order to be well established and to succeed, we need really a joint venture and a lot of community behind it. And that's an example of what WebAssembly is going to be. So let's see just a few applications, what WebAssembly could do for us and what it actually can bring us in this way. So this is, this is one, you know, it's a very simple game done by Unity as an example how they could use this to build their C and C++ game and put it into the browser. So this is a very, very simple game where there are some tanks, and I can play it with my keyboard. I'm very bad at this, as you can see. But you could navigate with this and kill each other with some tanks. Very, very simple things, you know. But you remember, this is something that has been written in C and C++ and compiled to the web just in a couple of days. Another cool thing that we could do with WebAssembly is some video things. There is a guy who has made a really nice video editor where, you know, where he's trying to compare JavaScript and WebAssembly performance. You know, this is just a small video here, and, you know, there are different things you could do here. On the right side, you could see the difference. So you could do something like this. And you can see it's not always the case that WebAssembly looks faster on our machine, or I can maybe switch to a webcam and hello everyone. So, you know, you can, this thing is already done by compiling code, of reusing code that has already been written and used in some other cases, you know. So now we could use this on the web. How are we going to produce WebAssembly? Well, as I mentioned, we are going to compile to it. WebAssembly is a compilation target. So we are going to compile to it from C and C++ as our main compilation source, but other statically languages are going to be supported as well. And we have a tool for that. It's called mscripten. Mscripten is a tool, or basically a project, including a lot of tools that allows us to manipulate and produce WebAssembly. And how this is going to happen? Well, we have this simple command that will allow us to say, hey, I have this source file out there, please generate WebAssembly for it. And it will generate the WebAssembly and a bit of glue JavaScript code that we are going to reuse. What is happening behind the scene though? You know, compilation process could be very, very generally split into two phases. We have the front-end compilation, where we have our source code, and then we produce something called intermediate representation, which is basically an abstract syntax tree of our source code. And then we take this intermediate representation and produce our output using the backend compilation. So this is like very, very simple way of describing what is happening when compiling a program. And what mscripten does is it uses clang for the front-end part, where it generates something called LVM, intermediate representation. And this representation is very well specified, because LVM is an open source project containing a lot of tools about compilers and compilation. And this intermediate representation is standardized, which means that if we have front-end compilers for other languages and we could produce LVM, intermediate representation, then it's going to be really easy afterwards to compile. And what we get here as an output is JavaScript. I thought it was an error, but it isn't. Because what we did is that we are getting a special JavaScript called asm.js. And asm.js is a subset of JavaScript, but a typed version. So it indicates to the browser, if the browser supports asm.js, that this piece of code is going to be typed. And how does it work? Well, this is an example of the same add function written in the ASM version of JavaScript. So, you know, you can see it's perfectly valid JavaScript. But what we do here is by using things like a equals a or 0, which is usually senseless because we know that it's always a. But if the browser virtual machine understands this, it will say, oh, a is an integer and b is an integer, and then the result is an integer. So I can optimize this piece of code to run with integers, right? And apparently this brings a lot of benefits out there. And asm.js was started by Mozilla a couple of years ago, and of course, it's still JavaScript, you know, it still has to be parsed. It brings a lot of good things though. That's why WebAssembly will reuse a lot of the knowledge put into this project and take it one step further. So we already have kind of typed version generated by mscripten. What if we could take this output and generate WebAssembly for it? Then we could be able to reuse everything that has been done there. And guess what? Such a thing exists. There is a binary in, which is a compiler tool chain to manipulate and do everything we want with WebAssembly. And the good thing is that it includes a tool called asm to asm. As you may guess, it takes asm.js and generates WebAssembly. So now we have the full cycle going from C and C++ directly to WebAssembly. But you saw also that the output was something JavaScript, and I mentioned a bit that what we get is a special glue code. And Emscripten generates this glue of loading assembly, because the basic things how WebAssembly is loaded in the browser right now is by, you have to fetch the file, maybe using the fetch API, and then you are wrapping into the array buffer, and you could call this one of these JavaScript functions. You could compile it to a module or instantiate it directly into the browser. So let's see how these things work out there. So I've prepared some very, very small examples in C. There is an obligation that every demo should have a hello world. So that's why I have written a very, very small program in C. By the way, I'm very bad in writing in C and C++. So if there is anyone of you who loves C and C++, please feel sorry. I feel really apologized for showing this code to you. But this very, very simple application, right? I have created a build command that runs exactly that command that I show you. Here I'm saying, hey, this is my source program. Please generate WASM, and the index will be index.js will be output glue that I want out there. And so if I try to compile this, this file will generate basically two files. It will generate index.js and index.ysm, and you can see them here already into the folder. And if I open the HTML file that I have generated, the only thing I do is I load the generated JavaScript file. So if I come back here and I open the hello world, well, there is nothing on the page. But if I open the console, of course, it has printed out what I wanted to print out, right? So this is very, very simple thing. You can write to the output, great, that's really cool. But we could also read. Another mandatory example is the Fibonacci series, right? So in this case, I'm reading from the input a number and then generating the Fibonacci series for that. Very, very simple thing. And of course, it wasn't me that wrote the C program. I just copied from the internet. So we do the same. I compile this, and if I open now, it asks me for a number actually. So I can write anything here, and then I have to stop the second time because it doesn't know. And if I open the console, it has printed out the Fibonacci series. So now I can basically read and write some stuff to the from input to the output. There is a really cool library in .NET called WebAssembly.NET, which allows us to manipulate WebAssembly ourselves. And this library allows us to produce WebAssembly ourselves. So this is, if I show you what this index.js looks like here that we generate from Emscripten. It's a very, very big JavaScript file. You can imagine, you can see it generate a lot of things there for us. But this is not really necessary to load WebAssembly. This is Emscripten's API for WebAssembly. Because the only thing that you need to do WebAssembly is something like this. Basically, you're fetching the file, then generating the array buffer, and then instantiating this. So it's just really a few functions that you do. But the cool thing is that we're going to see in a while that Emscripten generates a really nice API layer on top of it. So in this example, I'm going to generate WebAssembly myself by emitting directly WebAssembly and compiling it from C# with this library. So what I do here, I'm creating a WebAssembly module, and then I'm defining the function that I want to define. I'm saying that this function will be exported. And in the end, basically, this is the body of the function. WebAssembly is a stack language, so you could produce it like this. You wouldn't really do this in real life, but you could manipulate it with a simple program. And this will generate an assembly module for me. Oh, great. And then I can run actually this example in the browser, which generates a very simple thing. So this is C# basically generating WebAssembly. You could do this. The cool thing is that you can also read WebAssembly and call functions. So the same file, I have another project here, which it reads WebAssembly and say, hey, I have WebAssembly, and this is the exported interface of this file. So I can read the file, and I can basically read the exported functions of this file. So if I read the same file, it would just give me access to the same add function that I generated out there. So this is an easy way to manipulate basically WebAssembly in C#. The more important question is how basically .NET could benefit from WebAssembly. Most of us write in .NET, I would assume. So we would be, we want to reuse C# code, or maybe F# or maybe Visual Basic .NET if you're really into that. So the question is, what can we do there? Well, to remind us how .NET Think is built, basically we have all these possible languages that we could write in, and then we compile, and then we get something called common intermediate languages, right? And this thing is interpreted on the fly by the just-in-time compiler. And this is part of the common runtime. So in order to read and to execute .NET code, we need the common runtime to do this, right? So what can we do there? Well, we have basically two general approaches what we could do. The first one is, well, we could compile everything. We could compile the .NET runtime with our source code and produce one really big thing. And it works. I mean, Mono has done really nice examples on their website where you could do this compilation. Basically, it compiles everything into one executable file. And as you can imagine, the file size is kind of big, because you're compiling the runtime out there together with this code. So whether this is a good approach or not, maybe depends on your situation, but if you have a really big application, this could be kind of a problem that you're putting such a big file online. Another way could be that you're compiling only maybe the runtime and you're loading the DLLs separately, and basically you're creating your own runtime into the browser so that you could say, hey, I have this DLL, please load it for me. And they have also an example of this. But one really cool thing is this guy, Steve Sanderson, he showed really nice demo on NDC Oslo where he took something called .NET Anywhere. And .NET Anywhere, it's a very old project. It's a .NET runtime, very, very limited, but working out there. And he compiled this on the web and did some really cool stuff with it. And I am going to reuse what he did and extend it a bit and play around to see what other possibilities we have with WebAssembly. So, if we have to say to do the same function, right? This is a console application in C#. I have, the same Hello World application, and here I have preloaded the .NET Watson. This is basically the WebAssembly version of this .NET Anywhere that I'm going to reuse, and I'm using this here is the API that mscripton provides for me. So it provides me to do some arguments to the file and manipulate the files inside. So if I try to run this, nothing is happening, but you could see that it awaits an argument. This is a small application, but which awaits an argument, which is the .NET DLL that we want to do. So which means that I can see, hey, I can give you this argument, which is hello DLL. This is my app that I am building here. And I need to load two other, of course, the DLL itself. And there is the core lib, which is implementation of the contains implementation of some of the methods in the core lib that we are using normally in .NET. And by using this API, Emscripten has built this preloaded file system for us. So we can create a virtual file system basically into the browser by using this API. So if we try now to come back here, I can see that it has downloaded the file and it has executed this DLL. Well, very, very simple thing. I'm not doing anything here at all. So let's try to do a bit more funny thing. I have created something called an ASCII-art converter. And if you don't know what ASCII-art converter is, I'm going to show you first before I... So the idea here is that I have one input file there, and I want to upload a picture, and I want to transform this picture into just ASCII characters and print it out there. So I've written a small application to do that. So if I open here and say, I'll start with this, it shows me the picture on the left side, and it converts the things on the other side. So it reads everything that's written in the picture and converts this to an ASCII characters. So I can basically do some really cool stuff like this and play around with it. And the cool thing is that this picture doesn't really reach the server. There is no server in this case. Everything is happening on the client side. And if you want to see what is happening behind the scene, I have my program here where I have created my picture, which is my bitmap to ASCII function. And then here I have some JavaScript doing that. So basically, I'm converting this to array, the file that I select, and I am creating a virtual file to this. So basically, I'm copying the picture from the browser into the virtual file system that Emscripten has created on top of WebAssembly, reading this file and writing the output to another file, and then reading that file afterwards, and printing the output there. So, and this is built just everything with this API that Emscripten has done out for me. So by using this compiler stuff, we can actually do a lot of things out of the box. And whether we need it or not, well, it's up to us. We have the possibility for that, and we can basically use it. So this is like the first approach. Another approach to do things is basically to add WebAssembly as a target platform to .NET Core. In .NET Core, we have a very, very huge opportunity now to split all these classes into some base libraries that we can reuse. And one of the cool projects part of .NET Core is .NET Native, where it aims to compile your code and use some standard libraries so that the output of this will be one executable file. So it will be compiled to a native executable that you could run on your computer or distribute it easily instead of having the whole runtime there. And .NET Core has a project called CoreRT, which tries to implement this using the existing features that the .NET Core project has, like all the tools and the libraries that they have built for that. And the cool thing is that just a couple of days ago, a pull request was merged into CoreRT, which allows us exactly to do the same, to put WebAssembly as a target. So instead of getting an executable file maybe that you run on Windows, you could now target WebAssembly as an output from that. So you will be able, in theory, to get your C# targeting .NET Core and create a WebAssembly from that. This is in theory. In practice, it's still very, very experimental and very unstable, but you could go on their website and try to follow the instructions there. I kind of tried to do it in the morning, and my computer died. so I'm not trying it again right now. Another cool thing is that there is a new compiler out there called Lilac, and this compiler will be generating LVVM. And if you remember from the previous slides, if we have LVVM intermediate representations, then from there we could generate WebAssembly quite easily. So this is also another really interesting thing that could potentially work. It's not there yet, but it could be very interesting to see what is happening. So what's next then? We saw some things that we could do with WebAssembly.NET today, but you know, WebAssembly and .NET Core, they are still very new, both of them. And the question is, what is the next step out there? First question that we want to ask ourselves is, can we use WebAssembly at all? Is it ready? And the question is almost yes. It is already in Chrome and Mozilla. It is in Edge under feature flag. And it is coming soon in Safari. So it is almost there. We need some more time. But as I mentioned earlier, the community is really working hard on making WebAssembly fulfill all the wishes, because there are so many wishes out there. And if you check the GitHub repository, you will see how many things people want from that. But of course, it takes time to develop these things. And another thing is it the time for that? Well, you know, everything has the right time to be there, and WebAssembly comes in a time where, you know, JavaScript has already kind of conquered the web. You know, we do a lot of things with JavaScript today, right? And we can't really want something more. We want to do this cool stuff that JavaScript is kind of weird to use for, like video, gaming, and you know, these things where performance is essential. And WebAssembly is going to fill these gaps and allows us to bring the things to forward. So WebAssembly is going to change the web in a way that everything will be really a compile target way. So I would like to say thank you so much for attending my session, and I'll be happy to answer your questions.
Hey, thank you. What about debugging? Do you have a way to debug the compiled code in the browser? And do we have symbols that we can?
Yes, a good question. What I didn't say is that, well, no, the main representation of WebAssembly is a binary format, but WebAssembly comes also with a textual format, which is exactly the same thing, exactly the same instructions, but it's, you know, it's human readable thing that we could do. And one of the options is to use the textual format. Basically, you can generate source maps with that, and you could use this in the browser. But the best thing, of course, what you want if you're writing C and C++, the really cool thing that you want is to be able to debug directly this code from the browser, right? Yeah. And I have seen examples. It is very, very unstable, but I believe that it will happen soon.
Okay, thank you.
Yeah.
Hello. First of all, thank you for your presentation. And I have a question, whether we can access page DOM and things like WebSockets, local storage, and what else from WebAssembly, or we should still fall back to JavaScript for doing this?
Right now, it's not possible. So you have to go through JavaScript. But you can code JavaScript for WebAssembly. So this is the way to do it. But there is a request for that. So the idea is that in the next version or the next iterations of WebAssembly, there will be a direct call to this, all these web APIs like WebSockets, WebAudio, the DOM elements, etc. So there will be a specific API for these things.
Yeah. Hello. I could have missed this part, but well, my initial question is WebAssembly is naturally not supported by Internet Explorer because it is Internet Explorer. So if I one day want to write something in WebAssembly, well, I have a problem. I probably missed the chain, the compilation chain. is there a valid JavaScript somewhere in the chain which could be used instead by Internet Explorer with something like polyfills or something like that?
Yes, it's called ASM.js. This will be actually the polyfill. There won't be a specific polyfill, but ASM.js, because Mscripton generates both of them, so and they're perfectly valid. So you could use ASM.js in the browser and it will work.
And there is some code that chooses between ASM.js and proper WebAssembly? Or do I have the right? I mean, who controls what's used, what's not? Do I have to write some code for this?
You'll be checking. You can check if the browser supports WebAssembly, then you have to, of course, download the file and execute it like the examples, or you'll be downloading the ASM.js version of it. So you'll be checking this.
Thank you.
Yeah.
Okay. More questions? No? Okay. Boyan, thank you very much.